Now we want to discuss the next three or four types of redox reactions. So combination and decomposition is over. Okay, moving to the next, disproportionation. Disproportionation. Three more varieties are there. Okay. The next category is disproportionation. For that, we can set the next category as disproportionation. Disproportionation reaction. I think you are familiar with this disproportionation reaction. Here, same element oxidized and reduced. Okay, same element oxidized and reduced. Change its oxidation state from a common one to two different. From a common oxidation state to two different oxidation state. Changes its oxidation state from a common oxidation state to two different oxidation state. For example, the decomposition of hydrogen peroxide to form H2O plus O2. Okay, what happens? Oxygen which is in -1, and here the oxygen which is in -2, here the oxygen which is in 0. Before reaction, oxygen is in -1 in a common oxidation state. 2 oxygen is in -1, common oxidation state. After the reaction, it reduced, it oxidized. It reduced, it oxidized. The same element oxygen reduced and oxidized and become two different oils. Ready? The next example, that is white phosphorus in presence of alkali, disproportionated to phosphine and HPO2 minus. Phosphine and HPO2 minus. -4 plus 1. Here phosphorus is in 0. Here the phosphorus -3. HPO2 minus. -4 plus 1. That is -3. H2PO2 minus. Okay, -4 is 2. Okay. Well, the phosphorus is in +1. So reduced, oxidized for the same phosphorus. Okay. The next, that is sulfur in basic medium. Sulfur in basic medium may oxidize to and oxidized and reduced to form sulfide ion and thiosulfate ion. Sulfide ion and thiosulfate ion. I think you are familiar with this. We discussed the thiosulfate ion in the exceptional oxidation state. Okay. I'm sorry. In thiosulfate, each sulfur is in +2. Actually, it is +4, 0, but simply it is in +2. So this is 0, 0 to -2, 0 to +2. Oxidized and reduced. And from a common oxidation state, it becomes two different oils. Ready? The next category, that is the oxidation of chlorine in presence of base. A chlorine in presence of base, it may oxidize to. The base is concentrated, it may oxidize to chlorate and chloride. Chlorate and chloride. Ready? So from 0 to -1 and +5. Oxidized, reduced. Okay? Enough. Then one more type of reaction is also there. That is comproportionation. Comproportionation reaction. Comproportionation reaction. It is just opposite that of your disproportionation reaction, which means same element oxidized and reduced, but from it's a reverse of disproportionation. Same element oxidized and reduced, but the OH change is from two different values to a common. And this is from a common value to two different OS after reaction. Here, after reaction, or before reaction, it exists in two different value, and after the reaction, it become a common value or a single value, where the same element undergoes oxidation and reduction. So here, same element oxidized and reduced. Same element oxidized and reduced. Ready? Change its OS from different values to a common. Two different values to a common value. Listen, I'll give you examples. Let have copper CuO, Cu, CuO. They together forms Cu2O. Ready? Here the copper is in 0, copper is in +2. So copper exists in two different oxidation state. Now it is in +1. So it turns to a single oxidation state. So this is comproportionation reaction. Oxidized, reduced. For the very same element, copper. Then another example, Ag plus AgSO4 forms Ag2SO4. The very same logic here also. 0, +2, and here +1. Okay. So silver, before reaction, silver is in 0 and +2. And after reaction, silver turns to +1. Ready? So these all are said to be disproportionation and comproportionation reaction. Just opposite, where the same element undergoes oxidation and reduction. Next category, that is the last one, displacement reaction. What it is? Displacement reaction. Listen. Displacement reaction. Displacement reaction. Listen carefully. The general idea is let we have a compound XY, and if you are adding an elemental species Z to him, we have a compound XY, okay, and we are adding an elemental species Z to that compound. Then if Z more reactive than Y, if Z more reactive than Y, if your Z is more reactive than Y, then Z displaces Y. then your Z may displace the element Y. So your Z, which can displace, or simply the Y, now Y is getting outside, okay, because Z enters to here, and that is said to be displacement of Y by Z. So it become XZ. The portion of Y now it is occupied by your Z plus Y. So XY plus Z, and it become now XZ plus Y. Then the condition is that for the displacement of Z by Y, your Z should be more reactive than Y. And this is in a general displacement reaction. And we have two kind of displacement reaction. That is metal displacement. Listen. And what about the metal displacement? We have a compound. M. Listen, we have a compound My. And to that My, we simply add A. And now the A displaces M. A can displace M. Then what about the nature? AY plus M, right? And what about M? M is a metal. M implies metal. Then this reaction is said to be metal displacement. And what about A? A may be a metal or a non-metal. A may be a metal or non-metal. So how it become metal displacement? If the displaced element is a metal, if the metal which displaced by another metal, it should be a metal, then the reaction is metal displacement. If the element which displaced by another element is a metal, then it is said to be a metal displacement. Okay. Displaced element should be a metal. Okay. Ready. Now here the displaced element is M. M is a metal. And the displacement can be shown by A. A may be metal or non-metal. Ready? I'll give you examples. Listen. If you have a compound CuSO4, and simply I'm adding zinc to it, what happens? Zinc is a metal which have greater tendency to lose electron than copper. Here in this compound, copper is in the leaved form, electron lost form, or in the oxidized form. Okay. Now the copper is in the electron lost form or the oxidized form, but zinc have more tendency to lose electron than copper. So simply your zinc loses electron and zinc is able to displace copper. So whatever it may be, now it becomes ZnSO4 plus Cu. Okay. Whatever be the reason behind it, we simply check that the displaced metal is copper. Copper is a metal, and the displacement shown by zinc. Zinc also metal. So a metal which is displaced by another metal, that is a reaction. Okay. Let I have a platinum oxide, and I'm simply adding hydrogen to it. Okay. And what happens means your hydrogen can displace platinum. Then, because hydrogen is more able to lose electron than the most inert or the highly inert metal platinum. Okay. Hydrogen have greater tendency to lose electron than platinum. So hydrogen simply replaces platinum and it becomes H2O now, and your platinum is free. Platinum free. So the metal displaced is platinum, or the element displaced is platinum. It is a metal, and the displacement shown by a non-metal. Hydrogen is a non-metal. That is the idea. If the displaced element is a metal, then it is metal displacement, and the displacement can be shown by a metal or a non-metal. Ready? Okay. So like metal displacement, there is one more chance for your non-metal displacement also. Non-metal displacement also, right? So that is the last type of reaction. Going to that. Non-metal displacement. Non-metal displacement. Non-metal displacement. Listen. Let I have a compound Xn, and simply I'm adding A to that. Then if your A is able to displace the N, then what happens? The forms Xa and N become free, right? Yeah. Then what about the nature of N? N is a non-metal. N is a non-metal. What about A? A may be metal or A may be non-metal, whatever it may be. Okay, so what is the condition for non-metal displacement? The displaced element should be a non-metal, and the displacement can be shown by a metal or non-metal. Ready? I'll give you example. We know that if we have sulfuric acid and if you are adding zinc to it, what happens? And that is a preparation of hydrogen. You know, zinc is able to displace hydrogen. So the forms zinc sulfate and hydrogen become free. And there is one of the method of laboratory preparation of hydrogen, right? Yeah. So the displaced one is hydrogen. So element displaced is hydrogen. Hydrogen is non-metal. The displacement which is from a non-metal. Sorry, from a metal. So here a non-metal which is displaced by a metal. Oh, we can show another example. Listen. We have 2KCl and simply I'm adding fluorine to it. Okay, so here electron is dropped by chlorine. Sorry, electron is gained by chlorine, but in front of fluorine, fluorine will gain electron because fluorine have greater oxidizing tendency or electron gaining tendency than chlorine. So it become 2KF plus Cl. Whatever be the reason, simply you check that the displaced element is non-metal, yes. And the displacement is shown by metal or non-metal? Non-metal. So what kind of category this is? Non-metal displacement. Because the element which displaced is non-metal, then the category is non-metal displacement. And the displacement can shown by metal or non-metal. Like that, if the element which displaced is a metal, then it is metal displacement. And the displacement may be from your metal or non-metal. That depends. Okay. So these all are the important types of redox reactions. We are moving to the most important section, equivalent mass and balancing a redox reaction. Equivalent mass and balancing a redox reaction. So moving to the next category, that is equivalent mass. Equivalent mass. Okay. And equivalent mass will be discussed in a detailed way in your some basic concept in chemistry. Mole concept and equivalent concept are the most important cases though. Okay. So let equivalent mass of an element be E. E. Equivalent mass of an element be E. What about equivalent mass means? What is my equivalent mass? My equivalent mass is the weight of me or myself. What is the weight of me or mine? That have to combine, that is required to combine with the 8 gram of oxygen or 1 gram of hydrogen or 35.5 gram of chlorine. If I have 8 gram of hydrogen, 8 gram of oxygen or 1 gram of hydrogen or 35.5 gram of chlorine is the ready, and I'm doing to react with them. Ready? Then how much mass is required for myself to react with the specified amount, or simply 1 gram of hydrogen or 8 gram of oxygen or 35.5 gram of chlorine? How much mass is required? If 10 gram is required for myself, then my equivalent mass is 10. But if 50 gram is required for that combination, then my equivalent mass is 50. So equivalent mass is the mass of an element. Equivalent mass is the mass of an element which required to combine or displace. Which are required to combine or displace. Maybe the reaction is combination or maybe the reaction is displacement. Whatever it may be. Okay, but the condition is which are required to combine or displace 1 gram of hydrogen or 8 gram of oxygen or 35.5 gram of chlorine. That is the concept. Okay. So what is the mass that required to combine or displace directly for 1 gram of hydrogen, or it may be for 8 gram of oxygen, or it may be for 35.5 gram of chlorine. So equivalent mass is the mass of an element. Mass of an element required to combine or displace directly with what? With 1 gram of hydrogen or 8 gram of oxygen or 35.5 gram of chlorine. 35.5 gram of chlorine. Ready? And that is said to be equivalent mass. Equivalent mass. And the equation for equivalent mass is given by molar mass. Let equivalent mass. Equivalent mass is given by molar mass divided by n factor. Molar mass divided by n factor. So equivalent mass is given by molar mass divided by n factor. So you know what is molar mass? Mass of 1 mole substance. Ready? Molar mass of 1 mole substance. Mass of 1 mole substance. Equivalent mass. Mass of 1 equivalent substance. 1 equivalent substance. Mass of 1 equivalent substance. And what about n factor? N factor or valency factor. N factor is a constant positive integer term that depends on the species which are given to you. That is, if the species is an acid, then what is its n factor? For an acid, its n factor is Basicity. What is this n factor? Basicity. Ready? Ready? What do you mean by basicity? Number of hydrogen, number of ionizable H plus. Number of ionizable H plus. So it is the number of ionizable H plus. Just leave acid. Now we have base. For a base, what is the value of n factor? N factor is acidity. What do you mean by acidity? Number of ionizable OH minus. Number of ionizable OH minus. That is the acidity. The next, acid base over, then for a cation. In the case of cation, it is a positive charge. We know that cation is having some positive charge. So positive charge, for example, Al3 plus. The positive charge is 3 plus. So 3 plus is the n factor. Ready? We have anion. For anion, it will be the negative charge. We have salt. Salt is a combination of anion and cation. So anion part of a positive charge and cation part of a negative charge. Whatever be the positive charge offered by anionic part, that much negative part, cationic part, that much negative charge will be offered by anionic part, and the total charge will be 0. Okay, which means if the cationic part offered +2 charge, then anionic part should offer -2, because the net charge will be 0 for a salt, because salts are neutral, right? So in the case of salt, so what is that total positive charge, or what is that total negative charge? That is the n factor. That is the n factor. Ready? Ready? Listen. For an oxidizing end, you know what is an oxidizing end? In terms of redox components. In fact, in terms of redox components. Oxidizing end is something which undergoes reduction. So its oxidation state will decrease. So that decreased oxidation state. Decreased oxidation state. Okay. I'll give you a detailed explanation about this one, because our chapter is redox reaction. And in case of a reducing agent, reducing agent is something whose oxidation state is increased oxidation. Okay. So something whose oxidation state is increased, right? Yeah. So that what is the value for the oxidation state is increased? That is the n factor. I'll give you some examples. Listen. If I have H2SO4, the number of ionizable hydrogen which present in sulfuric acid is 2. So the n factor of sulfuric acid is 2, because its basicity is 2. Let I have NaOH. Number of ionizable OH minus which present in NaOH is 1. So the n factor of the base NaOH is 1. Have cation. In the case of cation, if I have Al3 plus, then number of positive charge is 3. So the n factor is 3. Let I have S2 minus. Here, this is an anion. The number of negative charge is 2. So the n factor is 2. Let I have a salt, Na2CO3. And we know that the total positive charge is +1 into 2 plus 2. The total negative charge is -2 into 1 minus 2. So the total positive charge 2, negative charge also 2. So that 2 value is the n factor. Okay. And I'll give you examples for this one. Okay. And that is a important section here. Ready? So this is n factor. N factor. Okay, and this is the concept equivalent mass, and you should know what is equivalence, number of equivalents, and what is the relation between number of moles and number of equivalents, normality and molarity, and what is the relation with n factor. So let me discuss that also, then we can move to a balancing.